Hey, ChemStars, this is Mrs. Vandalay bringing you another ChemStar video. Why? Because you're the star. Um, hey, we're back to this again. You should know the definition of chemistry at this point, shouldn't you? So what is chemistry? Chemistry is the study of the composition, structure, and the properties of matter. We covered those in 1.2.1 and 1.2.2. In section 1.2.3, we talked about the processes that matter undergoes and the energy changes. Well, 1.2.4, we're going back to the properties, all right? So the properties, we're talking about pure substances earlier. Remember the chocolate bar, pure chocolate bar. So what 1.2.4 is, well, what if we don't have pure substances, all right? We still have, it's still matter. If it's not pure, it's still considered matter. It has mass and takes up space. But now we have some new terms for that. So let's go to page 6 and continue on. All right, so 1.2.4 is matter and its properties, pure substances versus mixtures. All right, so what's our I can statement? We're going to be able to differentiate between pure substances and mixtures. What we did in 1.2.2 was pure substances, either a pure element or a pure compound. This is all about mixtures, all right? So our vocabulary is going to be pure substances. Sorry, it should just be pure, not pures. Mixture, heterogeneous, and homogeneous. So we have a few little new words in there for you, all right? So let's go through, and what this section we're going to do, we're going to identify everything here is going to be a mixture, okay? And how do you know if you have a mixture? The key word is and, okay? It is something and something. So a matter can be a pure substance or it can be a mixture. If it's a mixture, you have the word and, okay? It's a physical blend of two or more components and they can be physically separated. So for example, we have salt and pepper. We have peanut butter and jelly. Maybe a little bit more difficult to separate unless it slides right off the peanut butter, but oh well. All right, how about another one? Sugar and water. How are you gonna do that? You evaporate the water, you got your sugar back, right? Oil and vinegar. They don't mix. You just pour off the top layer, which is your oil, and now you separate them, all right? Well, carbon and iron, all right? What if you have like, charcoal that's been pulverized and you put iron filings in it, all right? So what can we do about that? Well, get a magnet. All right, and you can separate them. So you notice, what do these mixtures all have in common? It's something and something, all right? If I want to talk about a pure substance, I can talk about pure salt. But if you mix your pepper in it, it's no longer pure, isn't it? So that's a mixture, okay? And you can say the same thing about everything else. Carbon is a pure element, but you put iron in it, now you have a mixture. By the way, if you were to combine carbon and iron together, let's say, heat it up with the mixture together, you're gonna make steel. All right, steel is a mixture of carbon and iron and some other metals in there as well. Okay, so now we have two terms. Okay, mixtures can be either heterogeneous or homogeneous. Okay, I want to show you something real quick. All right, so do you recognize this? Oh yeah, those are those miniatures, right? So let me ask you this. Hopefully you all are familiar with dark chocolate, milk chocolate, Mr. Goodbars, and Crackles, all right? So I can use this as an example of heterogeneous and homogeneous. So mixtures can be hetero or homogeneous. Heterogeneous is a mixture that is what? Oh, this is important. That is not uniform throughout. Every little taste can be different, all right? What is a homogeneous? A mixture that is uniform. Oh, well, is uniform. It is the same throughout. So now what? Well, okay, what about milk chocolate? What would just plain old milk chocolate be? Heterogeneous or homogeneous? Think about it. Hopefully you said homogeneous. It is the same throughout. What about Mr. Goodbar? That's heterogeneous, right? Because you can get a nibble with just a chocolate, or you can get a nibble with the peanut in the chocolate, all right? And if you're allergic to it, I'm sorry. What about, what's next? How about dark chocolate? What would dark chocolate be? Hopefully you said homogeneous. It's the same throughout. And what a crackle? Yeah, heterogeneous, all right? It's not that you can get either the chocolate or the chocolate with a little Rice Krispie treat in there, okay? So, you can think of I can talk about chocolate and chemistry the entire year if you want me to, all right? But what are some other mixtures, okay? I don't know, do you like your Starbucks in the morning? So what would coffee be? Well, most coffee would be homogeneous. If you have this ice latte stuff, all right, the ice cubes are going to make it heterogeneous, but I'm just talking about like black coffee or even maybe coffee with milk in it, all right? You stir it up, it'd still be homogeneous, all right? Oh, speaking of milk, what would milk be? Well, it would be homogeneous. It's the same throughout, okay? You don't have to shake up your milk, do you? That's not why you have a milkshake. No, 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 no. All right, it's just homogeneous. Well, how about this Italian dressing? You know what I'm talking about? What's Italian dressing made up of? Well, oil and vinegar and spices and all that kind of stuff, all right? So is it the same throughout? No. All right, it is not. You might get a little piece of garlic in one bite and a piece of oregano in another bite, all right? So Italian dressing is not the same. What about sugar water? All right. As long as you have enough water that it all dissolves, it's going to be homogeneous. What if you put so much sugar in it that you have a whole bunch at the bottom of your glass now? Then it'd be heterogeneous, okay? But just, a normal amount of sugar, like if you want your sweet tea or something, it's going to be homogeneous. I have one more. Here we go. How about sand and water? All right, obviously they're going to separate out. It's going to be heterogeneous, okay? So hopefully that makes sense to you. Now, something else real quick. If water is present, it's going to be a solution. So what about Mr. Goodbar's? Water in there? No. Crackle? No. Italian dressing? No. It's usually oil and vinegar. I wouldn't, you might add a little water. I don't know, but no. All right. Sand and water, that would be a solution. All right. But the problem is it's not homogeneous. So I guess I wouldn't call it a solution. It has to be homogeneous to be that. Milk chocolate is not a solution, dark chocolate. Coffee would be, milk would be, and sugar water. So the last three are definitely solutions, all right? So if water is present and a homogeneous mixture, it's also a solution, okay? So mixtures can be separated, and here's our different ways to separate them: filtration, distillation, and separatory funnel. So what would a filtration be, all right? What's happening here, okay? We are separating, well, hang on a second. All right, my picture is too big. So, all right, so here we go. This is filtration. Can you tell what this is? This could be your sand in your water, couldn't it? If you have sand and water, you put it in a filter, the sand remains in here and the water comes through. So what is typically separating is your solid and a liquid, all right? A solid that is not dissolved in a liquid. So like I said, sand and water. All right, how about coffee filters? Does the same thing. It takes those ground coffee and it separates it out from the rest of the liquidy stuff, all right? So what about this next one? This is distillation. All right, so when do you have distillation? Well, typically, if you have a liquid and a liquid that dissolves in one another. So let's say alcohol and water. Okay, it's like rubbing alcohol. Rubbing alcohol isn't pure, it's called propanol. It's not pure propanol. It is propanol mixed with water. If you look at the label of your rubbing alcohol, it says, I don't know, 50% rubbing alcohol. All right, that means it is a solution. That means there's also water included. So what you would do is you'd put your rubbing alcohol in here. Rubbing alcohol actually has a lower boiling point than water does, so it will boil first, come through here in a condenser, so it'll make it a liquid, and now you'll have your pure rubbing alcohol here and your water remains behind, okay? But there's another situation where you could use distillation, okay? And that would be a mixture where the solid was dissolved, like your sugar water, all right? Now you gotta be really, really careful with this, all right? Why? Well, okay, you could break the apparatus if you boil it so much, all right, that all the water's here and you just have a solid here. You're probably going to break that glassware. It will work, I wrote, but you got to be careful, okay? Evaporation is a lot safer way, okay? So what about the separatory funnel? Well, that's when you have a liquid and, whoa, I'm so sorry. Come back here. Oop, there you go. That's when you have a liquid and a liquid that does not dissolve in water. For example, oil and water, okay, oil and vinegar. So that's where you put your Italian dressing in there, okay? So your oil would be on top, your vinegar would be at the bottom. You open this up and out comes the vinegar, close it up before the oil comes down, okay? So that would be your separation. Okay, let's turn the page and let's compare the idea of a mixture to a pure substance. A pure substance has a fixed composition. We talked about that before. That's why Hershey's, chocolate bar tastes the same every time because it has the exact same characteristic properties. And you can talk about pure substance by either being elements or compounds. So let's kind of put your diatomic in here too. So what are some examples of elements? Be magnesium, carbon, or iron. Again, think of your oxygen more as an element than a compound, so I'm going to stick it in there too. And then compounds can be broken down by heating or electrolysis. Electrolysis is via electricity through it. So you can break down H2O into hydrogen and oxygen by using electrolysis. You can actually break down molten salt. What does that mean? It's now liquid. If you have a liquid salt, and that takes like thousands of degrees, so you just can't do it with a Bunsen burner. But if you could, all right, you have this molten salt, put electricity through it, and you can get sodium on one electrode and chlorine on another one. And what about sugar? All you have to do is heat it up, all right, and it will decompose as well, okay? Don't try it at home. You're probably gonna make a huge mess, but it can be done, okay? So let's put this whole thing together, all right? So this is kind of summarizing everything that we've done so far, okay? So here we have matter, and the question is, can it be separated? Well, what do I call it if you can separate it physically? All right, can you separate it physically? That's what I'm talking about. It's a mixture. Like I said, if you have distillation or filtration or something, okay, you can separate it. What if you can't separate it by a physical means? Then it's a pure substance, okay? And then what? Okay, is the mixture uniform in composition? What does that mean? Well, is it the same throughout? Okay, is it the same throughout? Well, what did we say if it's the same throughout? Then it is homogeneous. What if it's not the same? That's your chunky stuff, all right? That's your heterogeneous. And what if your pure substance can't be broken down further? That's your compound. And if it can't be, then that's your element. So then what I put underneath here are some of those examples. So homogeneous, you have sugar, water, all right, and milk chocolate. It is the same throughout. Heterogeneous is your sand and water and your Mr. Goodbar. It is not the same. The sand's at the bottom, the water's on the top, Mr. Goodbar is, the peanuts in it. A compound is water, like we said before, just add electricity to it and you can break it apart. An element, if you add electricity to magnesium, you're just adding electricity to magnesium, nothing's going to happen, okay? And that concludes section 1.2.4. Once again, expect an objective check over this material. If you need extra help, watch this video again, look over your notes, and hey, don't wait to be great. We'll see you next time. Bye-bye.